Sweet. Okay, all right. Hey, great crowd. Thanks for coming out tonight. I'm curious, before we get started, who here is excited about animation? Oh, all right. Thank you. Thank you. You already have this. Now we're going to narrow down this group of people. How many of you are into CSS animation? JavaScript animation? Got any GSAP addicts in the house? Aw, well, hello, thanks for coming. I'm disappointed. GSAP is like the thing. Anybody personally identify as a motion designer in the audience? Okay, the motion designers did not get the memo about tonight. I'm so sad. But good to know, good to know. Sweetness. Moving along, you may know me from awesome projects like DevToolsChallenger.com, which shows off Firefox's really cool animation tools. I've helped clients build motion design into their user interfaces and their design systems at scale. Kind of an animation wonk if you haven't noticed the themes, so much so that I even wrote a book with a book apart. I do have copies for sale with me tonight if you buy me beers. And I've worked for Microsoft Edge, I've worked with Firefox, I've worked with the W3C for a long time. I'm a Google developer expert, and I just moved to Amsterdam to work for these people because, you know, only big companies need animation experts. So you're stuck with me, congratulations. But before all this, I used to be a professional cartoonist, and I made webcomics for teen girls for a living around the world, from the middle of nowhere in Virginia in the United States. Small town, you probably never heard of it. Eventually, I had to be an adult and get a real job making websites, of course. I thought I turned my back on art and creativity and storytelling, and that I would never tell stories again. In the meantime, I was learning a lot about all these cool new APIs that were coming out. And I remembered this guy here, Scott McCloud. He's my favorite author. He wrote a great book called Understanding Comics, and another one called Reinventing Comics, which is even better than Understanding Comics. Okay, once again, have you read Understanding Comics? Anybody? Anybody? It's your homework. Go home and read Understanding Comics. It's like the book that you should read if you're designing anything for anyone. But he also wrote another book called Reinventing Comics, which was all about how to use the visions of the future, where people would be able to draw comics on tablets in their hands, and there'd be this thing called micropayments, and well, his things keep coming true, little by little, in weird ways. So it's a great set of books to read. So I saw these APIs coming out, you know, like web audio and speech recognition and CSS animations, and I was like, my God, he was right. The internet is an infinite canvas. So I did this project with Adobe Inspire called Alice in Videoland, and I don't mean the Swedish Electroclash band, although I totally love them. This is the Alice in Videoland I'm talking about, and it introduced a lot of designers to the idea that they could code to create interactive stories at a time when Flash is decidedly uncool. So that was just a video. You could have used After Effects to make that, just recorded it and posted it somewhere. The CSS animations are very declarative. They're not very interactive. Interactive animation tends to need libraries like GreenSock or SnapSVG or Mo.js or other libraries that don't provide logos on their GitHub pages. That's why you're not listed here. Still, it was very tough because browsers weren't designed for animations other than, say, scrolling. Their rendering engines are not the same rendering engines you'd get with, like, say, a game. We've been missing out since the death of Flash, but all of that has been changing as browsers have been upping the rendering engine game. All right, so let's do a little history lesson here. Before CSS Animations or Transitions, over a decade ago, there was something called Synchronized Multimedia Integration Language, or we know it as SMILE. You can remember it's pronounced smile, like the facial smile. It's used to animate SVGs, and it was created by that slow process known as standards committees. So it was born in 1999, the good old days. So, 10 years later, 2009, nothing much has happened with standardized animations on the web, right? In the meantime, this thing called the iPhone is on the docket over at Apple, and it has a browser, and its developers, the Safari developers, They're thinking, how can we make the Apple website look as awesome in our browser, even though it doesn't support Flash as it does on desktop? What can we do? And they introduced the CSS Animations and Transitions standards. They didn't run them past anybody. They just kind of like swooped into the W3C and was like, I've got some standards for you, goodbye. And they ran away. And of course, you can imagine that all the other browsers were very happy that now they didn't just have one animation engine to contend with, they had 3 that they had to support. So Internet Explorer, at that time still something of an impactful browser in the world, was like, oh, hold on. 3 animation engines, you're kidding me, I can't possibly do that. No. Give me an API that I can use to describe the animations of all of these. One API to rule them all, an API that could underlie all the browser's animations while letting JavaScript developers access that animation engine. It was a really big API. After several years of drafting by that process known as standards committees, spec authors are finally nailing it down. It hasn't been changing too much in previous years, but we now know it as the Web Animations API. Hooray! Unfortunately, Chrome opted to deprecate Smile back in 2015, so it's kind of sort of dead, not really. But you know, like, good effort. Thank you for coming along. So we still have at least 2 of those engines. The Web Animations API is still a big deal for browsers and animation. You can already see it at work in browsers' animation development tools. For instance, these awesome tools that you can see. You've got timeline scrubbing, just like in the old Flash days on Firefox developer tools. I'm a big fan of Mozilla and their products, which is why I teamed up with MDN to document this API. Yeah, I love him so much, and I thought, who better to help me tell this story than Alice? So I brought her back, and she's going to help us today. So here's some core concepts. The Web Animation API is based on 2 models. It's got a timing model and an animation model, or I like to think of them as the when, as in when things are happening, and the what exactly is going down. Let's take a look at the timing model. So Web Animation API is time-based. Currently, all animations have a duration, or their duration is tied to something like a scroll input. But it has to know where it starts, where it ends, and how long in between. So these durations, they create timelines. Let's use the example of the Cheshire Cat. He disappears in 8 seconds, right? So we've got this timeline. We set him up from 0 seconds to 8 seconds, going from there to not all there. The computer knows what he looks like at any given millisecond along this timeline, right? So you could be anywhere in there, and the computer would immediately know exactly how much of the Cheshire Cat to show. This is a very efficient kind of animation. So, fun thing about this, because we've got these timelines, time may be shifted backwards, forward, scaled, reversed, paused, repeated. It lets us do all these kinds of things. We call this stateless animation. And it's pretty cool. You may be familiar with request animation frame-based animations. Well, they are a bit limited. They're limited by how often the page is repainted. Basically, it's if you have 60 animations and your frame rate is 30 frames per second, it's going to take 2 seconds to run that animation, as opposed to if it was running at 60 frames per second. But with the Web Animations API, if you say this animation takes 1 second to run, it will take 1 second to run, even if it's only got 30 frames per second. That's very important if you want to make sure that this thing is going to finish regardless of the frame rate. All right, let's see what else we've got in the bag. Oh, it's direction agnostic. This means it's super easy to run an animation forwards or backwards. It's a little harder to do that when you're building on a previous frame state. And it's seekable. You can plop down anywhere in that timeline and be exactly where the computer already knows. This means you are in sync no matter what. But why am I telling when I could be showing? The great thing about these is that timelines have a hierarchy and they inherit. So over on the left-hand side here, I'm making a bunch of cat elements. They all have CSS animations. And as you can see, those animations start at different times. On the right-hand side, each one of these animations is referencing that original cat's timeline and adopting its current time. So they're all running in sync. This is physically impossible with CSS animations alone. All right, this is very important for level 2 of the Web Animation API that introduces such things as grouping, but we won't get into that tonight. Timelines have children called animations. Animation objects line up along a timeline like trains on a track. They do this by connecting a single animation to a timeline and determines what the element, this cat for instance, should look like at any given point. The cat state from there to not all there is called a keyframe effect. The term keyframe is interesting. It comes from traditional animation. Keys, also known as key poses or keyframes, were the pose 1, pose 2, right? Those are the key frames or key poses, the keys. Now, if you work for Disney, you want to be the person who draws these, right? The keys. They got translated in interaction development over to keyframes. Now, if you are an intern or just a janitor or perhaps a Korean animator whose work has been outsourced to, you get to draw the in-betweens between those key poses. You don't get interviewed about what it's like to be an animator. This is grunt work. Nobody wants to do that. Computers are supposed to do that for us now. So those actually got converted over to tweens. It's interesting. Key got lengthened to keyframe, but in-betweens got shortened to tweens. So you've got a timeline, and you know what the thing should look like at any given time, but how do you make it go? Well, a good metaphor for this is that the animation object plays keyframe effects sort of along a timeline, sort of the same way a DVD player plays a DVD. I'm not sure that anybody even remembers how these things work, but let's hope that we are not all children. All right. With these two models combined, timing and animation, we're very fortunate because we can use the Web Animation API to run every single one of these animation engines, new and dead, in the browser. So here's how it's going to do that. I'm assuming everyone here has a good grasp of CSS Animations and Transitions. If you do not, you're fortunate because I happen to have a course for that, and you get 20% off with this key phrase here. But I'm going to assume you understand your CSS Animations and Transitions. Let's take a look at exactly how we use the Web Animations API to create those. We have this, because, in the browser, the Web Animation API is responsible for them. How is it doing that? Well, we got this animation player, and it takes a keyframe effect. Let's take a closer look at that keyframe effect constructor. What is a keyframe even? In the API, the keyframe effect tells the animation what it should look like at those key points, like the beginning and the end of the animation. And the animation model interpolates all the tweens, all the in-betweens, when he's halfway disappeared off that branch. This is from the original Alice in Videoland. It was done using a CSS transition. You click on the bunny, and the bunny, he has a transform set on him. Well, he has a transition set that's watching his transform value. When transform changes, it changes to the new value in 3 seconds. So when you click on him, he gets a class of interacted, and the transform value translates to translate Y 100%. That's what's moving him down. Here's that same interaction again with the Web Animations API. No CSS transitions. Oh, it's amazing. It works. It's science fantastic. I love it. Okay, let's see what exactly is happening here. We create this new keyframe effect, right? We pass it the DOM element we want to be watching and animating, and this keyframe object, which is just an array of little objects full of CSS key value pairs, right? We have to give it a before and an after at this point, although we won't always have to give it a before in future iterations. We also pass it this little timing object, which includes some key value pairs for duration, uses milliseconds, 3,000 of them, and takes things like fill for fill mode forwards. We're going to stick it in a var, and that way we can pass it to an animation object. Now, by the way, this is what happens if you do not set the fill mode forwards. When you click on that bunny, he's just going to pop right back to his original position. Fill mode forwards basically says, I want you to maintain the last key pose long after the animation has stopped playing. Sort of like when you're playing a DVD and you get to the end, it just kind of resets to the menu screen. Animations are like that. When they're done playing, they just kind of go, what? Fill modes are a nice way of saying, when you get to the end of the credits, just stay there. You can also use like fill mode backwards so that it starts at the very beginning. Just go read up on fill modes if you don't understand them. They're a lot of fun. So we know a lot of these options from their CSS counterparts. Let's take a look at some of our familiar friends. Duration, oh my gosh, it's transition animation, it's transition duration or animation duration. Delay, we know you. Fill, iterations, it's just a really nicer way of saying animation-iteration-count. They're so shorter, more concise, I love it. Direction and easing, oh, it's the appropriate term for that. Instead of animation-timing-function, it's easing, and instead of defaulting to the bizarre and unusual ease in, it defaults to linear, which is a constant rate of change, like sane people would write a spec. So, important for sequencing. Here's some shiny keyframe timing options. End delay. These are milliseconds to delay after the end of an animation. Really handy if you are staggering animations or playing them one after another. Iteration start, when the iteration for the animation should start. We've also got things like composite, iteration composite, which are just a little too weird to get into right now. All right, so now it's time to play said animation. We're going to do that with the animation object. Woo, make some constructors. So we got our keyframe object stored as rabbit down keyframes. And remember, if the keyframe effect contains all the info to execute an animation, the animation object is what's going to let us play it to execute it. How does that look? Well, we're going to take those rabbit down keyframes and we're going to wrap them inside a new animation constructor. And this thing here is the documents timeline. Why do we have to pass the documents timeline? Because an animation constructor requires two things, a keyframe object, and a keyframe effect, and a timeline. The spec has been written in a way that allows for different kinds of timelines in the future, for instance, a scroll-based timeline, or perhaps a gesture timeline. But for now, it uses the documents timeline. And so you pass it that. In this case, we're going to store it inside a rabbit down animation variable. Sweetness. Now, animation objects rock because they've got methods. What kind of methods? Familiar methods. Animation pause, animation can play, animation can reverse, finish, you can even cancel. Very important for when you want to have you just want to say, please, no, just drop it. I didn't mean that animation at all. Very handy. So we want to play that animation. We just do rabbit down animation, call the method of play on it. We wrap that inside a function, down he goes, which we use on the event listener for click. So when people click the white rabbit, down he goes, fires, and the rabbit down animation plays. And after it's over, we remove the event listener. Just got to clean up after ourselves. So, well, that was pretty amazing. It's the Web Animation API. I was expecting applause, but there's no applause. That's okay. It's all right. That was a lot to go through for 2 lines of CSS. Thank goodness we have a shortcut. We got this lovely thing called the animate method. It's great. You can call it on any DOM element. It's fun, fantastic, right? So if you're a CSS Animations wonk, you may have noticed that the Web Animation API, it totally handled this transition like an animation with a big pile of keyframes. Oh my gosh. Am I at 7:30 or 7:40? We can do this. All right. Anyway, all you have to know is that is kind of interesting, but we're going to look at the CSS animations and how they're done with the Web Animation API right now. You can't see it quite well, but she's changing colors as she's spinning. We're going to reproduce this set of CSS using the Web Animations API's shortcut, the animate method. So basically how it works is you get your DOM element, you call animate on it, you pass it keyframes, you pass it some timing options, and boom, you get an animation. Here's how we converted that CSS over into a keyframe object. That looks really good, doesn't it? I mean, you can almost read it. It looks like CSS, feels like CSS, must be CSS. Wonderful. Especially notice here that we have this thing called offset. Offset's important. We'll get to that. This is the timing object. Once again, we've got the duration of 3,000 milliseconds, iterations infinity. Nice use of the capital I infinity there. We're going to put them together. So element becomes document get element by E. We're going to go get Alice. We call animate on her. We pass the keyframes, Alice tumbling. We pass the timing, Alice timing. And boom. So the offset is actually making up for the color change at the 30% line. Offsets are a way you can tell the different animation to only run at a certain time. Otherwise, that color change would have run around 50% of the way through. Offsets are pretty cool. I'd go into them more, but I don't have the time. Let's talk about what you're really here for, callbacks. Okay, now you're here for the promises, but I like callbacks. So I didn't come here to show you the long way to do CSS animations. Let's look at the cooler things that we can do. That animation object gives us some nice attributes. It lets us do decidedly more than CSS does. You get this on-finish promise, this on-cancel promise. Oh my gosh, there's a ready promise. So many promises, and it keeps them all. Pending, which is read-only, it's Boolean. It basically informs you that the animation is waiting to run. Play state, which is read-only, you use methods to change it. That's a way if you can check it to tell if it's like paused or it's running. The playback rate, we'll get to you later. And effect, which is kind of like the animations version of this. It points to the keyframe effect. Yes. So the animation's keyframe effect and its timing and animation props. One day we might have other kinds of effects, groups, sequences, more on those later. For now, we just have a keyframe effect. All right, more fun animation attributes. There are a couple of others. We've got current time, which gives you the location where you are on your current timeline, and finished, which is a callback, and I like it. We're going to play with these two. There's a famous scene where Alice is drinking and eating, and she's growing bigger and smaller, and I thought that would make a really fun little game. It would be very hard to do this with CSS animation alone, but I thought surely this is a job for the Web Animations API. And this is kind of what I had in mind here. You click and hold the Eat Me cupcake and she gets bigger, or if you go over and click and hold Drink Me, she gets smaller. Oh, so cute. She's such a cute little girl. I did some fun stuff with the SVGs over there. We can talk more about that in another talk, but anyway. The way to think about this is that Alice is on a timeline. She's going from big to small. And when the game starts, we've got, hey, go back there, big to small. And when the game starts, she's right here in the middle. And we're using the cupcake and the drink to move her forwards and backwards. We're scrubbing forwards and backwards along that timeline. So first, we use the animate method. We go out, we get Alice, and we have, the tiny part where she's scaled down to half her size, and the big part where she's up to twice her size, and the timing options. And then we have to hit pause. Fun thing about the animate method is that it runs it immediately. So if you want it to not run immediately, you always end up using pause. You can see it all over in people's animation patterns. The organization is considering whether or not it should run automatically, given how often that happens. All right, so let's play it through. Sweet. That's what happens when you don't do animation pause. So we're going to pause her. And an Alice change, pause. Great. Well, now she's little. She's at her beginning state where she's super tiny. And this is what it's like when she's at her finished state. We use finish to set her back to the finished state. We want her to be halfway between those two states. So we're going to set her current time, Alice change.current time, is going to be equal to, oh my gosh, it's a really long way of getting this, Alice change. Oh, it's going to be effect. Yes, it's effect, timing, and duration. And that sets her current time to the end. We're going to divide it by half, and boom. Now we have set her current time to be halfway of her duration. And we're referencing her duration, so we don't have to make it a variable that we maintain. So clever, but so long in a selector. These slides are all available online, too. Don't worry, I'll give them to you afterward. And then we set these controls. So we've got the timeline. We've set the playhead. Now we need to control the playhead on that timeline. We're going to use the cake in the bottle to send it forward and backward. We know forwards already, so let's go backwards. How we do that? We change the playback rate to -1. So Alice change, playback rate, -1. And we hit play. And we tie that to whenever somebody goes mouse down on the drinking event. Let's take a look at how that looks. And we go over, we hold down, and all of a sudden, the animation is playing all the way backwards. There's some other fun stuff that we do to make this fully work. To hit pause when the mouse up has happened, we basically make this stop playing Alice function, and we add a listener to all kinds of things. But we're running out of time. It has two endings. In the story, Alice wants to get through a tiny door, so she eats the cake, but she gets huge. She can reach the key to the door, but she can't get through it. She throws a tantrum. She cries her eyes out. I know exactly how she feels. When she drinks from the small bottle, she gets so tiny, she ends up swimming around in a pool of her own tears with this mouse, makes some really racist comments to the mouse, who promptly cold shoulders her and swims away to safety while Alice continues to flounder about. That sounds like a great Saturday night. So I made little vignettes for both of these scenes, her being too small and forgetting the key, and her being too large and crying herself to sleep. Well, good thing we have two more timelines in both of these little animations, the eating and drinking animations. And what happens is that when we get to the end of one of the animations, when either runs out, what we do is we animate. When either one of these animation ends, what we do, and I'm not going to show you the code for this, is we animate where her current time is on that timeline. And we find out if she is overall at the beginning of her timeline, indicating she's smaller, and we play the small looking up at the key vignette, or if she's toward the end, we play the one where she's too big. It's cute, it's fun, it's a great way. You can check out the slides and more of the code pens on the interwebs. In the meantime, I am going to skip ahead to give you some fun information on other things we can do. For instance, there's another demo where you can actually change the playback rate to make them go faster when you click on them by multiplying that playback rate by like 1.1 over and over again. And there's a decay on the playback rates of the things all around them. So the more that you click on them, the faster they go. And it also changes the rate of the things around them. It's great. It's from the Through the Looking Glass game. I love it. You should check that one out too. Anyway, go to the code pens, explore. So Rachel, when can we use this API? The good news is you can start using it today. In fact, I recommend that you do so. It has, there's a polyfill, which all these demos use. I don't really recommend using the polyfill, but if you are catering to people on Internet Explorer, you might. Features are rolling out in Firefox and Chrome all the time. I believe Firefox is completely feature complete on this. Edge, from the people who suggested the API in the first place, has moved it into their hopper. For full support and coverage, in fact, I actually recommend that you use Edge's API catalog to look up the support, because Can I Use doesn't really get into the granularity of which methods are supported, et cetera. So visit status.microsoftedge.com to see the details of each property and its support. If you want to see it in Edge, go to user voice and vote for it. As for WebKit, WebKit's actually pretty darn awesome. They have been doing some great work with this API. It has started showing up in their dev preview on iOS and desktop. So we know that it's coming to iPhones everywhere very soon. Very excited about that. The Web Animations API is showing up in the wild. For instance, Stripe is using it in their payment processing animations. There's a really cool write-up on that online. And it's also showing up in a few animation libraries like this one, Just Animate, made by a great community member of the web animation community. Hopefully, big animation libraries could build on top of this API for improved performance and accessibility. And it would give tools like Spirit.js, et cetera, a nice export format for us to interface with. And of course, more implementation means we're going to have better tools across all browsers, including ones like Chrome Canary. Level 2 of the spec introduces grouping and sequencing, which changes everything, gives us a very Flash-like interface to work with. Dan Wilson wrote a great post about it. I recommend you go there to read more about it. So all animation is time. All the Web Animations API is time and change. And that, well, it changes everything. It makes way for the future animation specs we haven't even met yet. and the future of animation online. I would like to thank a couple of great people, Alex Miller for helping me with some of my in-betweening, Opal Essence for doing the logos, Chris Mills at Mozilla for helping me with all the documentation, and Brian Bertels, the author of the spec, for answering all of my questions. I hope you had a good time tonight. Allison, I thank you. If you want to learn more about the Web Animations API, visit rachelnabors.com/WAAPI. You can sign up for webanimationweekly.com, the newsletter, to get all the latest news on this API in your inbox every week. And you can join the Slack Animation at Work community, where you can get your questions answered by the API's authors and more. Thank you very much for your time. It's been a pleasure.